Hello, today we will be studying metallurgy. It is a part of our class 10th syllabus and a very important part. We get a handful of questions from it. So first of all, we will divide the metallurgy syllabus into 4 or 5 sets. So today we will discuss the number 1 set, that is basically what I call it metals and metal activity series. So our first part that we will study is metals and metal activity series. So basically here we will study about the properties of metals, properties of non-metals. The questions that are generally asked are from the exceptions, not from the normal properties of metals that we talk about. So in each property of metal we have to always find out if there is some exceptions or not. Similarly with the case of non-metals. So we'll discuss on the important points regarding to this part of metallurgy. So first of all, let us deal with the properties of metals. What are the properties of metals and non-metals? Subsequently we will do that. So first, if we go through the properties of metals, the number 1 property that comes apparently to our eyes is basically luster. What is the meaning of luster? Luster means that whatever it shines is luster. It's basically the shining nature of the metals that we call is lustrous. So if you take a piece of silver, it shines, it's lustrous. Take gold, it shines, it's lustrous. So normally the metals are lustrous. The first point is metals are lustrous. So normally we can say that the metals are having luster. Now if I go to the non-metal side of it, non-metals are not lustrous. Now coming back to exceptions, we should know which are the non-metals which are lustrous. So there are some non-metals which are lustrous like iodine and graphite. Graphite is an allotrope of carbon. These two are lustrous. Number 2 property. Number 2 is malleability. Metals are generally malleable. Malleable means whatever that can be beaten into sheets is basically malleable. Now I have to find out, again I will go to the exceptions. What are the metals which are not malleable? So the exceptions over here is, remember these are non-metals. These are non-metals which are lustrous. Now coming back to malleability, the exception lies in metals which are not malleable. So those are zinc and mercury. These cannot be beaten into sheets. Basically zinc is very brittle and mercury, as we know, it is at room temperature, it is at a liquid state. Number 3 point is ductility. What is ductility? Ductility means, now what was malleability? Can be beaten into sheets. So basically we can make sheets out of it. Ductility is can be drawn into wires. So if we see aluminium wire, copper wire, these materials can be drawn into wires due to the property that it possesses because it was a metal. Now what are the exceptions that are there in metals which are not ductile? Well, there are many. Easily we can find out the examples which are called, which I will say exceptions. Again Zn because it is brittle. Again mercury, and you can take gallium also, which is also liquid at room temperature. These two are also exceptions for malleability. Now next point is hardness. So metals are generally hard. Now can we name some metals which are not hard? Yes. There are metals like sodium, potassium which are not hard. obviously your mercury is not also hard, because mercury is also liquid. But we are trying to find out other exceptions, so I am writing different examples in different cases. Metals forms alloys. This thing we are learning from class 6th, 7th, 8th, 9th, and now also metal is forming alloys, and it will continue forming alloys in your life. Now we know that metal forms alloys, there is nothing exceptional to it, everybody knows. So nobody is going to ask you any question about whether the metals form alloys in class 10th level. People may ask you, is there any non-metal that form alloys? Yes, there are two non-metals that form alloys. Number one is carbon, number two is phosphorus. Sometimes sulfur also forms part of some of the alloys, but basically you have to study carbon and phosphorus. If anybody asks you, name a brittle metal, then what should you say? Brittle metal. What is brittlety? Brittlety is it breaks. So it cannot be ductile, it cannot be malleable. So the brittle metal you can write over here. Brittle metal you can write as zinc. It breaks. Look, this mercury and gallium, though they are liquid, they will not break, but zinc will break. So brittle metal is zinc. Is very important. Okay, metals that form alloys, we know all the metals form alloys. So these are again non-metals which forms alloys. Okay, so high tensile strength, metals have high tensile strength. Exception again zinc, mercury, gallium. Metals always have high melting point, boiling point. So we have to also check what are the exceptions for that. High MP and BP. We are all talking about metals right now, but I am putting in the non-metal part of it. As in the alloys case you have seen, metals forms alloys, but the exception is that there are two non-metals which forms alloys also. Here there is high melting point and boiling point. Normally all the metals will have high melting point and boiling point, except there are some exceptions. In case of metals like mercury, gallium, cesium, they are liquid at room temperature. Liquid at room temperature. Do not write this symbol at exams, okay? This is only for me. So these are liquid at room temperature. Comparatively, if we go to non-metals, non-metals will be either liquid or mainly gaseous at room temperature. So what are the non-metals that are solid at room temperature? There are many non-metals which are solid at room temperature, like sulfur, carbon, iodine, so etc. These are non-metals solid at room temperature. Okay. Now, metals are, look at this point, metals are with high MP. So, this may not be having that high MP over here. Iodine is not that high MP wala non-metal. Similarly, sulfur. But if you see carbon, carbon has a very high MP. Now if I ask you which are the non-metals which are having very high MP, then there are three non-metals: carbon, boron and silicon. Very high MP, very high melting point. Carbon, boron and silicon, very high melting point. Okay, next another point, with respect to electricity, metals are good conductor. Now what are the exceptions over here? Which is the metal which is not a good conductor? Identify? No? Tungsten. Nowadays we are using many LEDs and stuff. I don't know, maybe some of you are still having those yellow colored light bulbs in your house, and if you see the filament of that, it is still tungsten. That is having high resistance, high resistivity. You may have read in your physics book, current electricity chapter, and it is a bad conductor. And only due to the reason that it is a bad conductor, it is used as the filament. Because it would have been a good conductor, it would have passed on the current altogether and you would have got light energy out of it. Now, so metals are good conductor. There is exception. This is the exception. Tungsten. It's not a good conductor. Now non-metal, if I come to non-metals, are normally bad conductor, but there are exceptions like, now this is easy, graphite, then gas carbon. These are non-metal. These are all allotropes of carbon, but they are good conductors. Density. If we come to density, metals are having generally high density. So which metal is having low density? There are two metals which we know usually floats in water: potassium and sodium. Exception. Low density, low. And non-metals are generally having low density. If we see oxygen, nitrogen, all are having low density. But there are some non-metals which are having high density. Like if we go for exception again, diamond, which is basically a allotrope of carbon, and it is having high density. So see, we have gone through so many exceptions in a very short period of time. So if we recapitulate, what did we get? What did we get at the end of it? Because we have segregated this one as metals and metal activity series, and I have discussed a lot of exceptions that are there within the metals about the properties, about the normal properties, and about the non-metals about their normal properties. There are some exceptions. Now what I have to understand is, if we jot down what are the exceptions, it is very easy to remember. It's not that very hard. So metals are, first of all, I said metals are lustrous. Every metal is, almost every metals are lustrous, except zinc. Zinc is not that lustrous if you see, but still it shines. It's not like that it doesn't shine. But if you go to non-metal, non-metals are normally not lustrous. So what are the non-metals that are lustrous? Iodine, graphite. These are the non-metals that are lustrous. Iodine is difficult to remember because you do not see that in daily life. But if you go for graphite, you see that in your pencil. It shines. It does shine. So it is lustrous. Next, if we go for the malleability, next point was malleability. Malleability is beaten into sheets. You always combine the malleability and ductility together. Malleability is any material that will be called malleable when I can beat it into sheets. I can beat it into sheets. And ductile is if I can draw it into wires. So in both the cases, normally metals are ductile and malleable. But what are the exceptions? So the exceptions are quite similar over here. Zinc, gallium, mercury. Gallium and mercury are liquid. So obviously you cannot beat it into sheets. You cannot beat the liquid into the sheets. You cannot do that. Zinc. Zinc is common to this. What is the reason that zinc is non-malleable and non-ductile? Because zinc is very brittle. Zinc breaks. So the brittle metal was zinc. So obviously a brittle metal cannot be beaten into sheets, non-malleable. It cannot be drawn into wires. non-ductile. Over, done. So again, if I recapitulate again, iodine and graphite was not a metal but lustrous. Zinc, gallium, mercury, non-ductile, non-malleable and brittle. Next is metals from alloys. Now, which are the non-metals which form alloys? Carbon, phosphorus. This thing you have to remember. This needs some memory. Okay. And metals generally have high melting point and boiling point, except some metals which doesn't have high melting point and boiling point. The exceptions are again liquid at room temperature. What comes to your mind? Mercury, gallium. It's done. Another one adds into it. Cesium. Over. Next, which are the non-metals which are having high MP and BP? You go for very high MP or BP that we have discussed. Carbon, boron and silicon. They have very high MP and BP. There are some non-metals which are solid at room temperature. Which are they? Iodine, carbon, sulfur, etc. So, like this you have to remember. Next is, metals are good conductor. That we have studied. We know. Now, which metal is not a good conductor? Tungsten, electric bulb. So, the bulb in your mind should glow. Which are the non-metals that are good conductors? Because non-metals are generally not good conductors. You go for this oxygen, nitrogen. These are not good conductors. Which are the non-metals which are good conductors? Graphite is a good conductor. This you have studied in class 8 already. Graphite is a good conductor. And there is another addition, that is gas carbon. Which are the metals which are liquid at room temperature? We have already studied. I am just recapitulating it again. Cesium, mercury, gallium. There are 3 metals which are liquid at room temperature. Cesium, mercury, gallium. Which non-metal has very high density? It's again an allotrope of carbon. So allotropes of carbon are very important. If you go for diamond, it is having a very high density. If you go for graphite, it is a good conductor of electricity and it is lustrous. If you go for gas carbon, it is again a good conductor of electricity. So allotropes of carbon that you have read in class 8 becomes very important in class 10 also for short questions. If we go for low density metals, because metals will be generally having high density. So for low density metals, it will be potassium and sodium. So these are the things that we have studied and you must have noted it down. So this is the part 1 of the metallurgy chapter. First thing is understanding of metals and non-metals. What are the exceptions? Next step, we will understand how the process of extracting out metal from its ores are carried out. So before that also we have to learn some principles. After that we can go into the process. Thank you.